How do I reflect an image over the x or y axis? So in this section, you're going to be reflecting images over a line of reflection, and then you're going to be reflecting them over x and y equals lines, the x and y axis, and a y equals x line. So to start off, write this down. Write down that when an image is reflected over a line, corresponding points stay the same distance from the line of reflection. That's the only thing that you really have to remember about reflection, is that when an image is reflected over a line, corresponding points stay the same distance from the line of reflection. Period. If you're given a triangle, whether it's in picture form, coordinate form, no matter what form it's in, you've got a triangle over here on the left, and it's ABC. Okay? And each of these vertices have coordinates. And you're asked to reflect it over a line. Whether the line's horizontal, vertical, angled, it doesn't matter. If you're going to take that image and you're going to reflect it over a line, it means you're going to pick this image up, you're going to flip it over the black line, and it's going to end up over here on the right side of the line somewhere. The new points A, B, and C have to be the same distance from this line of reflection. If you call this your line of reflection, if point C is 3 units from the line right here, then the new point C has to be 3 units from the line. So this point right here would be C prime. If point A is reflected and it's, it's going to be out here somewhere. It's going to be the same distance from the line of reflection. Okay? If maybe B is 5 units from the line, then B prime has to be 5 units from the line on the other side. There's your new image. Alright, let's do another example where it's got to be reflected over a, let's do it over a horizontal line. Okay? You can say that triangle, XYZ. And let's say that X is at 2, 1. And Y is at 3, 4. And Z is at 4, -1. Is reflected over Y equals -2. You know, graph the new image, or graph the image. Alright, the original triangle, the original shape, that's called the pre-image. The shape after it's been translated, in this case reflected, is called the image. So the before is the pre, the after is the image. So if you're given a coordinate, or you're going to draw a coordinate plane, and I'm going to probably run out of room here. Alright, so we got point X at 2, 1. So 2 and 1. And Y is at 3, 4. Point Z is at 4, -1. You're going to reflect it over Y equals -2. So when it gets reflected over Y equals -2, you gotta identify Y equals -2 first. Well, here's -2 on the Y-axis, and Y equals -2 is a horizontal line through -2. There's the line Y equals -2. So now this image has to get reflected over that line. Corresponding points need to stay the same distance away from that line. So if you take this image and it's up top and you're going to flip it over the red line down to the bottom, none of the X values are going to change, are they? Your X values won't change. Okay? So you've got point X right here, X prime, instead of having a, let's see, how far is the Y value of this point from the line of reflection?
3.
It's 3 units, isn't it? So how far does it have to be below the line?
3.
It's got to be 3. So it's got to move 6 places, doesn't it? All right. So it's got to be down here. Where does it got to be? Can anybody predict that one? X prime's got to be at 2, -5, doesn't it? Okay. And right here, point Z is 1 unit away from the line of reflection. So it's going to stay 1 unit away, but it's going to be on the bottom. So Z prime is going to be at 4, -3. And then Y prime y prime is going to be down here somewhere, and it's 6 units away from the line of reflection now, isn't it? So it's got to stay 6 units. So y prime will be down here somewhere at 3, -8. Alright, that's going to be your y prime. And then connect the dots. All right, here's a couple rules to write down for reflection. If we're reflecting over the x-axis, okay? Over the x-axis, you have a point, xy. When something gets translated over the x-axis, its x's stay the same, and its y's become opposite. Okay? If you have to reflect a shape over the x-axis, you have your original, you have your pre-image, your pre-image is at xy, it gets translated, the image is going to be at x, opposite of y. If you're translating or reflecting a shape over the y-axis, your pre-image is going to have an xy value. Each point will have an xy value. After it gets reflected, your x's will become opposite and your y's will stay the same. When you're translating over the y-axis, or I'm sorry, reflecting over the y-axis, your pre-image will have an x and a y value. Each point will have an x and a y value, and after it's translated, the new x value will be the opposite of the original, and the y value will be the same. And if you have to reflect an image over the line y equals x, over the line y equals x, all right, the line y equals x on a coordinate plane looks like this. That's the line y equals x. If you have to reflect an image over that line, then your pre-image will all have vertices that are at xy. After the translation, your images, your new image will have vertices that are at yx. Meaning, if this point was at 3, 4, okay, after the translation, the point will be located at 4, 3. Okay? You will get much more out of reading these concepts. The 3 key concepts: 4 key concepts in this section than you will any notes you can take down. So if you start working through the assignment and you get confused, read those key concepts. If you're still confused, come see me. Here's some practice for you today. Page 628. (18 through 28). Check headline and answer your focus question.